Imagine that every elevator in the world suddenly loses its brakes and falls toward the bottom of its shaft. Could the combined force of all those impacts cause a global earthquake? First, we need to make an extreme assumption. Every safety system fails at the same time, allowing every elevator car to fall all the way to the bottom. There are approximately 22 million elevators worldwide. For this estimate, we will assume that each elevator car, including its load, has an average mass of 1.5 metric tons and falls an average distance of 20 meters. The gravitational potential energy released by one falling elevator can be calculated with a simple formula. Energy equals mass times gravitational acceleration times height. That gives us 1,500 times 9.8 times 20, or approximately 294,000 joules. That is about 290,000 joules. After falling 20 meters, the elevator would be traveling at nearly 71 kilometers per hour, just before it hit the bottom of the shaft. For anyone inside the elevator, this would obviously be a disaster. But from the Earth's perspective, that amount of energy is only equivalent to detonating about 70 grams of TNT. One falling elevator is nowhere near powerful enough to cause an actual earthquake, but there are approximately 22 million elevators in the world. If we add all their energy together, we get 22 million times 294,000, which is approximately 6.5 trillion joules. That is equivalent to detonating roughly 1,500 tons of TNT. Using the standard relationship between earthquake magnitude and energy, where the base 10 logarithm of energy equals 1.5 times the magnitude plus 4.8. The result is equivalent to an earthquake of approximately magnitude 5.3. It sounds as though every elevator in the world falling at the same time would be enough to make the entire planet shake. But we have overlooked one important problem. The world's elevators are not all in the same place. An elevator falling in New York City and another falling in Beijing would strike the ground about 10,000 kilometers apart. Even if both impacts happened in the same second, their vibrations would travel along different paths and arrive at different places at different times. Those vibrations would have different directions, frequencies, and phases. They would be absorbed by buildings, scattered by layers of rock, and might even partially cancel one another out. They would not automatically combine into one larger earthquake. More importantly, the mechanical energy released when an elevator hits the bottom of its shaft would not all enter the ground. A large part of that energy would crush the elevator car, damage the buffers, bend steel structures, shake the building, and produce sound. Eventually, much of it would become heat. Only a small fraction would actually be converted into seismic waves. So, if every elevator in the world fell at the same time, it would not produce a magnitude 5.3 earthquake. Magnitude 5.3 is only the theoretical upper limit obtained by concentrating all the mechanical energy in one location, and assuming that 100% of it becomes seismic waves. In reality, the result would be more than 20 million separate local impacts distributed across cities around the world. Nearby seismometers might record brief human-made vibrations. There is only one even more absurd scenario that could bring us close to the result we calculated. Move every elevator in the world to the same location, stack them inside one gigantic elevator shaft, and then drop them all at once. Only then might the concentrated impact approach the energy of a magnitude 5 earthquake. So, if every elevator in the world fell at the same time, you probably would not feel an earthquake. But you would feel the morning rush in the stairwell the next day.